Hi everyone, in this video I'm going to demonstrate on how to create a model, analyze, design and produce a report using FrameCE. First, go to Files menu, New Project and start from one of the templates here. I will choose this 3D frame and declare the dimensions. Height is 3 meters, then 5 fixed. Then I'm not gonna add materials yet, so I'm going to go straight to the model. Exit. Now this is the initial dimension of the frame that I'm going to model. Then from here I will add more beams and columns, loads and all those kind of parameters for the model. Okay, and then I will add a beam along the x-axis. So for that, I will click this button and then select the initial point or the first node of the beam. And then since it is along the x-axis, I should give the length along the x-axis. I'll have it as 6, and then for dy and dz are 0. And click apply. Then I will add another beam along the x-axis, and this time it has 3 meter length. I will add one more, still 3 meter length. Then I will add a beam from this node going to the z direction. So dx is 0, dz is the length of the beam. Say it's 5. I will also do the same here. 5. I'm going to do similar length here, 5 and then 5. Then I'm going to add another one here, another one here, and then click exit. Now I can also add elements by just clicking the two end nodes if I have all those 2 nodes already in the model. And to do that, click this button here and then select the end nodes, right mouse click, and then I will add more beams here, right mouse click, and then exit. Now I want to have columns of similar length like this one here. So again, I will click that button, then select the node, and then the length of the column is -3 because it's below the initial node. Apply. I will do the same here. I'll do the same here, here, this one as well, here, and then here. Then exit. Now I want to create an intermediate beam that intersects at the midspan, at the midpoint of this element. So for that, I have to create a node at the midpoint. So select this beam, then divide button and then select number of segments or declare segments. 2. I will also do similar segments in these beams. So select this button, segments 2. Okay, now I can now declare, I still have to divide these two beams as well. Okay, so I can now add intermediate beams. So since I have now all the nodes for each beam, I'll just use this this button and then select the end nodes. Right mouse click, right mouse click, right mouse and select. Okay, now if you observe here, I have these two beams supposed to be intersecting, but at this time they are not, because they are not connected in a common node. So I have to divide, or I have to let these two beams intersect at a common node. So after selecting these two beams, click this intersect button, and then now they are subdivided and connected at a common node. So I will do the same for these two beams here, for these two beams here, and these two beams here. So I have now the intermediate beams created. Now I'm going to add a second floor, similar in dimension and geometry with this first floor. So what I'm going to do is just to copy all these members by selecting all the elements, and then click this clone button, and then click OK, and then reference node, OK, and then select the destination node, OK, and now I have the second floor identical with the first floor. Now I don't want these elements here, so I can just select these elements and then select this delete button, yes, and now I have just a portion of this of the first floor in the second floor, so it's not entirely identical now. So this is the way to do that. Just copy, and then if you don't want, you can delete the element. Now next is to add a support. Well, as you can see here, I only have supports in these 4 columns. So I need to add supports in the new columns by selecting the nodes and then right mouse click, edit node properties, declare the nodes as having a footing, and then fix, and then exit. Now I have all the supports. And now the next thing I will do is to declare the section properties of these frame members. Now at this time I only have one section, which is, as you can see here at the bottom right corner, just a 150 UB. Now I will add more section properties by going to the materials menu and then add button, and then add button again, and then declare or add more section properties. First, if it is a concrete section, you have to declare the properties of the concrete as well as the steel. Okay, and now declare that it is a concrete section, and then start adding your section library. I want to have a beam which is 300 by 600, so I will declare the dimension here and then click OK button. As you can see here, there is a 300 by 600 section, concrete section here. Then one more, and then add button, user defined. I want to add 300 by 500 beam. Okay, and then one more column. I will add a 500 square column. Now I have 3 section properties on top of the initial one. Click OK. Now I can start changing the section properties of these frame members. First, I want to have all the columns of the same size, for example. Select all the columns and then edit beam properties. 500, select 500 square, apply. I want to have beam. Okay, I think next, and then edit beam, apply. Now you can see here, when there are more and more beams and columns, it will be hard for you to select an element because some might be obstructed by other elements. So there's a way to get rid of the obstruction. So go to Elements menu and then select this Smart Layer button, and FrameCE will automatically create layers of its floor. So here I can hide level 2, so I can easily work out the elements in level 1. So I can now easily view members in level 1. And then right mouse click, apply. Then I want these intermediate beams to be 300 by 500. Apply. And then I can go to view layer and then this time hide level 1 and show level 2. So I can change elements and level 2, not this one, edit beam 300 by 600, and I can change these elements here to 300 by 500. Now I can view all the layers and it's done. The next thing I will do is to create load cases. I'll go to Loads menu and then click the Create button. Currently I have 2 load cases, the did load and the live load. I will add another load case, a primary load case. Say, for example, did load 2. And then since it is a did load, I will include the self weight and then click add button. I will add another load case, which is live load 2. Add, and then I have now 4 load cases. I will add another load case and then say, for example, wind load X direction. Add, and then another load case, which is wind load Z direction. Add. At this time, I won't add earthquake because I have to add. I have to declare the did loads and live loads first before going to earthquake load. So now I will use the stick model. The next thing I need to do is to create slab loads. So there is an option here for smart slab loads. Click the smart slab loads and then declare the slab thickness and the pressure load. So if it is if you are currently in did load, as you can see at the bottom left corner, that means the pressure load here is for did load. So click there's also an option here for conventional and decking. Conventional meaning your reinforcement is your typical reinforcement, so it's conventional. Decking is when you are using a decking system for your slab, which is not the case in this example. Okay, so I have now declared the properties. Click the OK button, and FrameCE will automatically create the slab loads. Now, if you don't want some of the slabs here, you can easily delete. Say, for example, I will delete some of the slabs here. For example, I want to delete these slabs, this and this one, and then OK. So now I got rid of those 2 slabs. Now, as you can see here, if you view the slab loads, in did load, I have the loads from the slab, but in live load, I don't. So I can add slab loads for live load by going to the loads menu and then edit slab. Then select slabs and then declare the pressure load here, 30. Okay. Now if I go to another load case, did load 2, I only have these small loads because this is only from the self weight of the slab, but I don't have the superimposed did load 2 yet. So for that, click the edit button and then select the slabs, or you can window select the slabs and then declare the pressure load here. Okay, you can also change some of the slab loads. Okay, here, so go to other load case, edit, and you can select slabs, whatever. You don't have to select all of them. And then, yeah, this is it. I have now all the superimposed slab loads for the 4 load cases. Next, I will add wind loads along X direction. So I will assume that the wind loads are acting as a uniform or distributed load along the columns. So select the columns, right mouse click, apply element loads, and then along X. So say for example, 100 kilonewton meters, kilonewton per meter, and 100 in node 2, then apply. Okay, so then I can change the graphic scale for the element load, except I will also add wind loads along these on these columns, say 50. Then I will add wind load along Z direction. Along Z, say for example, I will also add the loads on the other side of the structure. Okay, and then I have now dead load, live load, dead load 2, dead load, live load 2, wind load X, and wind load Z. Next, I will add seismic load by clicking this new seismic load button, and then type the seismic load case name, seismic X, and then declare the load factors. So I will assume that it will use 100% of dead load and 25% of live load. I will select options based on the standard. And then assume it's a moment resisting frame, intermediate. Then since it's along the x-axis, so the angle must be 0 here. Okay, here. So I have now a seismic along X. Then I will add seismic load along Z axis. The same. And then if it's Z axis, so the angle must be 270 if it's going to the negative. Okay, here. Now I have all the loads: dead load, live load, wind load, seismic X, and seismic Z. The next thing I will do is to create load cases combinations. So I will go to loads menu and then create button, then add load combinations. I will add load combination for dead load and live load. The load factors are declared here. Now, it doesn't mean that you have to use all these, similar load factors, depending on the standard you're using. So you have to use what is recommended by your standard. I will add load combination for dead load 2. Another load combination for wind load. I will add another load combination for wind load in Z direction. And wind load or load combination in earthquakes, and combination of dead load and earthquake. So all these load combinations really depends on what combination you want to include. And again, I want to emphasize here that I'm not using similar to your load factors because I don't know your load factor combinations. I'm just using made up combination cases here just for the sake of giving you a demonstration. I will add a load combination for serviceability, wherein you can check your deflection. So say dead load plus live load. Okay, now I have all the load combination cases. I can start the analysis. Okay, so I can check the deflection for dead load by clicking this Y displacement button. If I want to see the deflection in live load, I'll go to live load case. To load combination cases, I can also view them by changing the load case options here at the bottom left corner. Okay, now I can also view the shear and moment diagram by clicking this button and then select the elements to view. Here you can view the shear and moment diagram. Close, and then you can also produce a report of your analysis by clicking this report button and select the load cases to be included in the report. So I will select all the load combination cases except the serviceability, because this is only for deflection. Or I can include if I want, of course. Maybe I'll just include this serviceability and then click OK button. And then select all elements. Then you can also unselect some of them. I can say I don't want to include some of them. Maybe this one as well. And then OK button. And FrameCE will generate a PDF file for the analysis result. So this is now the analysis report in PDF. It will tabulate the moment, the shear, the right moment, the right shear, and shear for the beams, and for the columns, it will tabulate the axial forces as well as the moment in both top and bottom nodes. So you can save this. I will save this as my analysis report. And then close. The next thing I will do is to go to the design. Now, it's very simple in FrameCE. You don't have to worry about design if you use this go to design menu and then select this design plus plan full design. So FrameCE will automatically design each and every element in the frame, and just select, or you can also have the option of choosing which element will give a design calculation. You can unselect some of them. But this, even if you unselected some of them, it will still be designed and the only things that it will not produce, those unselected elements will not produce a design calculation, but still it will be designed. Then click OK button, select the rebars available. You have the option of choosing the face of the column for the beam design, and it will give you a smaller moment compared to the center of joint. Now click the OK button, then select the load combinations to include in your strength design. I have to unselect this load case 15 because this is only for deflection. This is not part of the strength design. OK button, and then project description, sample, and designer's initial, OK, and then declare the soil bearing capacity, ultimate bearing capacity. OK button, and then from here, FrameCE will design all the elements individually, and you don't have to do anything. Just wait for the software to complete the design. Now it's currently designing the footings, and footings are the last elements to be designed. So once all footings are designed, the FrameCE will stop and gives a summary of the design in Excel, as well as produce a draft of the framing system. Now the design is complete, and FrameCE plots the framing system in, and FrameCE will plot the framing system in AutoCAD. It will also tabulate the beam schedule, the column design schedule, and the footing, including the reinforcement, the concrete volume, and the reinforcement weight. Now you can view the calculations here in this folder, because FrameCE will automatically create a folder for all the design outputs here. And FrameCE will also produce a report of the design by clicking this report button, and then select the elements to be included in the report. You can select all, and you can unselect some. You can unselect all of them, or go back to select all, then click OK. Then FrameCE will generate a report of the design. So this is the design summary report for beams. It includes the element number, the length, the width, or the section dimension, and the reinforcement here. Then it will also tabulate the footing design. FrameCE also plots the structural framing plan. So if you go to your AutoCAD, you can open the structural framing plan drafted by FrameCE. FrameCE plots the beam size plan, the bottom bars, the column, the footing, the top bars, and the stirrups. This file, for example, shows the framing plan of the design. So here, and I will hide one layer. No. See here, this is the framing plan of the beam size. You can see here the dimensions of the beams. You can also view the this is the bottom bars plan. See here, it shows reinforcement for the bottom bars. There's also a plan for column size. It shows here the column sizes, as well as the stirrups. See here, it shows the stirrups and the spacing. So you see here, FrameCE not only design, it also plots the structural plan. Okay, so I'll close now and go back to FrameCE. So I think I have to stop here. I have shown you how to start the model from scratch until the completion of the design and the drafting.